Advanced Algebra Data and Statistical Reasoning Standard 2.5. Let's take a look here. First, a definition. Normal distribution is a distribution that forms a bell-shaped curve. Characteristics include the following. It's symmetrical. Okay, so it's the same on both sides. You have many measures near the middle and fewer measures the farther you go from the middle. Okay, so if you're a bit from the middle, it'll be a few, but when you get even farther out, there'll be progressively fewer measures. Okay, this is a look at the normal distribution. This particular one's called the standard normal distribution, where we have a mean of 0 and a standard deviation of 1. These are standard deviations. Okay, we talked about in an earlier video that these are also known as z-scores. How many standard deviations are you from the mean? So if your mean is 0 and your standard deviation is 1, it's easy to compute, or at least easy to think about these measures on the bottom. Now, the empirical rule is a rule that establishes how much of the curve is so many standard deviations away. Okay, so the empirical rule states that if you're 1 standard deviation away, so if you're either somewhere between 1 below and 1 above the mean, then that has about 68% of the data, roughly. It's not exactly 68%, but so between these two inner red lines, 68% of the curve is accumulated. If you venture out 2 standard deviations from the mean, you have 95%. Again, that's from here all the way to here. It leaves only this small part and this small part that's not covered. And if you venture 3 standard deviations away, so between these outer red lines, you've got just about the entire curve. You can barely see this little bit here and this little bit here, but the part that is under the curve is 99.7%. Now, to understand, I'm going to go away from the slideshow just a minute to kind of give you a sense of what this curve is telling us. Okay, so if we go to Desmos here, right here we have a certain percent of the curve that's colored in. Now, these are different numbers, but we're just going to focus on what's shaded. So about 7% of it's shaded at this point. So what this does is called a density function. It's not really worried so much about how high this is. It's worried about how much is filled in. What percent of the curve has been accounted for as I work my way from left to right. Okay, in this instance, the purple shaded is 7%. But if I were to change, that's at the number 12 in this example. If I were to go to 14 though, let's do that. Let's go to 14. Notice that now you have a more significant portion that's shaded. This would be about 31%. Okay. If I were to venture to 15, okay, that's exactly 50%. And you see that symmetry there. So that's the idea that's going on. It's not so much the height that we're concerned about, it's how much area has been captured as you go from left to right. Okay, so it's important to understand that. It's important to understand what's going on here. All right, so if you were to break down those percentages, remember it's 68% from here to here. So if you break that in its symmetry, 68 divided by 2 is 34. It's actually a little more than 34 on each side, but it's roughly 34%. If you were to consider from here to here, remember from here to here is 95% on the previous slide. So if you subtract the 68 and divide by 2, you get these each to be 13.5%. And if you go the 3 standard deviations away, the 99.7, and do the math, they're 2.35% here. And this is exaggerated a little bit, this particular illustration, but these small areas, which are actually smaller than what you see, is only 0.15% when you're 3 standard deviations away. Notice also the symbols at the bottom. The Greek letter mu means mean, and the Greek letter lowercase sigma means standard deviation. So this is the mean, the population mean. This is a population mean plus 1 additional standard deviation. This is a population plus 2 additional standard deviations, and so forth. So if you're doing this by hand without the aid of technology, you'll need to remember these percentages. So here we have the weights of a football team has a mean of 225 pounds and a standard deviation of 5 pounds. Label a normal distribution with these weights. Okay, so we've done that here. The mean is 225, and we're going to add 5 3 times going right, and subtract 5 3 times going left. Okay, so you can see that on the football team, you got lots of folks here in the 220s, fewer under 220 and fewer above 230, but particularly very few under 210. Now, there's a few out here, but not many, and very few above 240. Okay, so to label one of these is just simply add and subtract the standard deviation from the mean and to put the mean in the middle. We can use this now to estimate some percentages. Okay, so there's the same curve. Find the percent of weights below 220. Okay, so I'm not going to go back to the previous slide. I'll just remind you that this section was 13.5, this was 2.35, and this was 0.15. So below 220 would be the sum of those three, 13.5 plus 2.35 plus 0.15, and that's 16%. And that looks about right. That's roughly 1/6 of the curve is to the left of 220. Above 235, again, I'll remind you, this is 2.35. Remember, it's symmetrical, and this is 0.15. If you add those two up, you get 2.5%. And we could do it between 210 and 240. Now, if you'll remember from our first slide, or one of our earlier slides, these are each 3 standard deviations away, so we had the empirical rule say that would be 99.7%. Just about everybody's between 210 and 240. Now, we did the percentage based on the exact standard deviation values. If it asked a question, what about, say, 222, what would you do? Well, you'd have to convert with a z-score and either use technology or a z-score table. This slideshow will focus on technology because that's part of the standard. Let's look at that. Different situation. The mean height of a tomato plant is 15 inches with a standard deviation of 2 inches. Use technology to find the percentage of tomato plants that are, and I'm going to have to go away from this slide and go to Desmos here. Now, there's Desmos, there's also Texas Instruments calculators and other uses, other ways of finding this. I'm going to focus on the Desmos here. Okay, so we're going to use Desmos to figure this out. So 15 inches is your mean and 2 inches is your standard deviation. So it says below 14 inches. We're going to leave this slide. So I'm going to hit escape, and it's going to show you the answers in the future questions. But let's go ahead and focus back to this. I'm going to go from scratch here. How do you get that curve up there? You type in normal, DIST, short for distribution, parentheses, 15 for the mean, comma, 2 for the standard deviation. Okay? And then you would click find the cumulative probability. Now, mine, it was already pulled up. Sometimes it'll be this little hourglass. You can click on it to get a good look at the picture. But notice that it gives you a max and a min, and it starts with, well, every possibility. Everything under the curve would be 1 or 100%. It does give probabilities here. We want to know, if you'll remember, let's go back to our slideshow, below 14. So for that, what I'm going to do is just put in I could have left that negative infinity. I probably should have left it, but it's okay. I can just put something really small. Let me put negative 1,000, which doesn't even make sense here, but that's easily small enough, to 14. Okay, so essentially we're saying this is below 14 because negative 1,000 is so far over there. So that would be 30.8%. That's where I had this measure there, 30.9 if you round it. Okay, between 10 and 16 inches, I'm going to say the min to 10. The max to 16. This is a good opportunity to look again to remind you of what a density function does. The fraction under the curve is our answer. So the fraction that's shaded in, not this part here or this part of here, but the fraction that's shaded in is roughly 68.5%. So 68.5% of our tomato plants are between 10 and 16 inches. And you can see that here. And finally, above 16.5, let's go once more. And we'll say 16.5. And our max, I'm just going to put something huge like 1,000. Okay, that's way off the page. And it's roughly 22.7%. Okay, and that makes sense. That looks right. That looks like roughly a quarter of the curve if you're estimating. Okay, and you can see 22.7%. So let's look at the standard. And again, those are those answers. And of course, we could do more there. I could show you z-score tables, but I'll leave it for now with those ideas. The standard says, given a normally distributed population, estimate percentages using the empirical rule, z-scores, and technology. So hopefully we've done that here. The empirical rule, remember, this is the 68, 95, 99.7 rule. Z-scores, you can use the z-score formula, which I didn't show here, or use technology to help find that. But it's all about the percentage under the curve that tells you how many fit the particular criteria.